So following the part 3 of artificial neural network, so we are on the last slide, and here we see that what are the new trends over here in the artificial neural network. So if we have, like, 5 to 10 layers, we need a GPU, which is graphical processing unit, and a faster computer, and we also need a label training set, a large label training set for that one. Okay, so now what are the improvements in that one? We The improvements are, like, responsive activation functions, which is called relo, which is based on the input. So if the input is, like, less than 0 negative, so the value of y will be 0. If the response is, like, positive, so like if the value of x is positive, so the y value be also the positive value of based on the input value. So that is the relo. I will show you the function shortly. And then we have, like, regularization, like, normalization, the dropout functions over there, supervised pre-training, that how the supervised pre-training is done, and unsupervised pre-training as well, which is called autoencoders. And we have a specialized kind of ANN. For images, usually we use convolution neural network, which is like, performing very well for image data. And for sequence data, when we have some sequences, like, some series kind of data, or some, like, financial traits, or if we have, like, genomics data, genes related data, in that case we use the recurrent neural network, which we call it RNN. And, like, in case of we have, like, skip connections, then the residual networks is also very important, right? And we have also the very advanced one, which is called, like, generative adversarial network, which is called GAIN or JANE. Okay, so these are the different, like, deep learning trends here. Okay, now let me show you some practical example. Let me first show you the relo. So what is a relo? So just to make you short, that what is a relo over here? Relo is basically, yeah, that is a relo. So relo is, like, some functions. So if you're, like, if the value of x is less than 0, it means negative value, so your function will be automatically turns to 0. So for example, if your x is -5, so the y function or f of x will be 0. If it is f of x is, like, even 0, the function of x will be 0, right? So here, if x is a positive value, it means that, like, if x is a positive value, then so your y will be dependent, means f of x will depend on the value of the y. Okay, so this is, like, real functions. Okay, now looking into the some, I want to give you some example which is related to the ANN. This is a very good example I found on the Kaggle. It's about the rain prediction, whether it will be raining or not. So uh, they have, like, put an example of rain in Australia, that how the rain in Australia will be, like, progressing, and how it will look like, and how we can predict the rain in Australia. So they have collected certain data. These are the libraries like, which is used for the ANN. So especially the important libraries are sklearn, right? And Keras is also used as, like, a very important library for ANN. Okay. So these two libraries are most important used here in the artificial neural network. Apart from that one, the data set is, like, very good heavy data sets we have it, which is, like, available. You can download it and you can use it, and it has, like, almost 143,000 records, which is a large data sets. So this is, like, info about the data, how your data looks like. So it has almost 22 attributes. If you look at it, it has a 22 attributes. Okay, and you can see which start from the date, locations, minimum temperature, maximum temperature, rainfall, up till to the whether it will rain today or rain tomorrow, right? So these are your, like, predictions attributes. And after that one, if you look at here, like, if you look at this one, there is some, like, some visualization it has been done over here. Visualization is related to the data. The author has done a good work. Like this is the data that whether it will rain tomorrow or not. Okay, and this is the count how many meter the rain will it will be there in Australia all over the year. This is the heat map they have generated for it for all the for all types of temperatures. Okay, so now you will see. Now I will. Now there is some more information on that one. This is about the more classifications or not classification. I mean some more a visualization of the data. This is sine of encoded month. This is a cosine value. So sine divided by cosine we got the tangent value. So Tesh value we call it. Tesh value is obtained from it. And if you see over here there is some more calculations on that one. I am interested to take you to the most important thing, which is about the artificial neural network. This is the data pre-processing. Before processing the data, you divide the data into the training set and into the test sets. Okay, and based on that one you have some more visualization here. If you go more here, so this is model building. This is very much important, and how you make your building, how you make your model building. And if you look at this one, this code is they are using the activation function, as I told you about the relo. They are using the relo, even they are using the sigmoid. Okay, and you have to find the accuracy. This is very important. And entropy for the impurities, or we call it like loss functions. Okay, these are important things which I want to highlight for you, that how these have been used. So usually you don't need to code more, you just need to use the pre libraries or import the libraries, and it will generate for you. So the epochs I talked you in the lecture in part one. Epochs is mean like the iteration, like in the first iteration. So it has 150 epochs. See, so it's starting from 1, 2, 3, 4, 5. Okay, and every epoch it is telling you about the accuracy. That initially our accuracy was 78%. So validation accuracy was 78%, and the loss was 0.3 is 39%, right? Accuracy of the full accuracy was 0.78 means 78%, and this is validation accuracy. Validation means the test accuracy, and loss is this one, right? So here you see the normal loss and the normal accuracy of the overall function, and the training set, and this is the validation loss and validation accuracy, right? So we have categorized this in a two parts, right? And then moreover, if you see over here, this 150 epochs has been done, and at the end, when we saw that the accuracy is not changing that much, it's like regularly repeating. So if you might seen that this one is the 158 iterations. After 158 iterations, what we have done, we have got the accuracy still 83% and 84%. So 83% is for the training sets, right? And for the testing or validation set is 84%, right? So this is how the accuracy is found in Python about the artificial neural network, and I hope you enjoy it. And this is more plotting that how your training loss and validation loss is working across the all the epochs. So epochs is very interesting terminology, and you will learn more about it while you practice more artificial neural networks parts. Okay, and then you have seen that there is training and validation accuracy, so it also goes parallelly. If you see over here in this graph, so what is the conclusion? So you test on the test set, and then you evaluate the confusion matrix and evaluating the classification report. So you see the confusion matrix. So in the classification class, as I already told you that how the confusion. So this is prediction line, right? This is a prediction line, right? And this is the error, okay, in your yes prediction. Okay, this is your error in the yes prediction, and this is the error in the no prediction, right? So this is 75% is your prediction, right? And and I can say 9%, okay, 9%, 9.5% is your misclassification or misprediction, right? So this one shows the error in this one, and this shows the error in that one, right? So this is the overall, like confusion matrix, right? And it also tells you some more statistics values, which is very important with regard to, like recall value. We also, like in the classification, we also found that how to find the recall precisions value, which is depending on the false positive, false negative, and true positive, and true negative, right? And support value. Support is also very important, especially in KNN algorithms. We use that one, right? So this is all about today's example of the artificial neural network, and I hope you will have enjoyed it, and see you in the next series. Thank you.